Alright, so for page 56, we're just going to do a few examples, 4 of them, on solving rational equations, and we will use each method at least once. And so you can just title it examples. The directions say to evaluate, that's the same word as solving, so evaluate each of the following equations for the indicated variable. A couple of things to note. It says, this is a vocabulary word, a proposed solution, proposed as in one that you're saying is a solution, of the new equation that is not a solution to the original equation is called an extraneous solution. So what we're doing is we're going to be manipulating these equations, creating new equations. And so what's end up going to happen is we're going to have a new equation at the very end that we go to solve, but without, it wasn't exactly the same as the original equation that you began with. It looks a little different, but it will have the same solutions. But sometimes when you're doing this, you end up sometimes you end up with an extra solution. And then when that becomes the case, the solution is called extraneous. And so the second note then is that it says that you have to make sure that you check your answers in the case that you do end up with extraneous solutions, because you have to throw those away and cross them out if they end up not working. Okay? So the first example that we're going to have then is going to be this one. It says we have 4 divided by x plus 3 plus 5/6 is equal to 23/18. And so I have fractions here that I want to set equal to this fraction. I want to know what x is to make this a true statement. Well, I would like to use the cross multiply method, but in order to do that, I need to make sure this 5/6 is over here on the right side. I need to combine my fractions as best I can. And because the 5/6 is a number, and so is the 23/18, I'm going to put these numbers together by getting a common denominator. So I'm going to use method 2, which is cross multiply. When I go to subtract my 5/6, because I want to subtract it from 23/18, I need to get a common denominator. When I do that, I end up with 23/18 minus 15/18, which is the same thing as 8/18. That can be reduced down to 4/9. And so now what you have is that you have 4 over x plus 3, which is one single fraction, and then 4 over 9 was a single fraction. It's separated by an equals. At this point, we can go ahead and cross multiply. When we do that, we get 9 times 4 from this cross, and then 4 parentheses x plus 3 from this cross. Now at this point, this is an Algebra 1 problem, so you can go ahead and solve the rest of this. 4 times 9 obviously is 36, but then you're going to go and divide both sides by 4 here in order to solve for this x. And so when you do that, you end up with 36 divided by 4, which is going to give you 9, which is equal to x plus 3. And then the final answer then is x equals 6. You would plug that back in here, make sure that it works out, and when you do, it really will give you 23/18. For example 2, we have these expressions. So we have 7n over 3n plus 3 minus 5 over 4n minus 4 equal to 3n divided by 2n plus 2. For this one, I'm going to end up using method 3. Remember that method 3 says you can get a common denominator on both sides first, and then set the numerators equal, so that's what I'm going to do. The problem here is I can't see what the LCD is going to be between all 3 of these fractions, so I'm going to go ahead and factor. When I do that, I'm going to take out a GCF from each denominator. So if you put all of these together, your 4 and your 3 will be 12 for part of your LCD, with an n plus 1 and an n minus 1. This one already has one, so I don't have to include another one. So my LCD then is going to be 12, n plus 1, n minus 1. So notice the left side is just going to be a normal problem like I would have asked you to add or subtract. The right side is going to be very similar. We want to give it the same LCD that the left side has. And because it has equals, I can just simply set the numerators equal once those denominators are also equal. So on the left side, I'm going to get a common denominator, which looks like this. These are the pieces that I need to multiply by in order to get my LCD for each of my 3 fractions. And then I'll go ahead and multiply these guys out. Notice that you have 1, 2, 3 fractions. All of them have the same denominator. So I'm not going to get rid of that denominator and look at only the numerator and set them equal. So 7 times 4 is 28. You've got your n, parentheses n minus 1. 5 times 3 is 15, so minus 15, parentheses n plus 1. And then 3 times 6 is 18 with your n, and then parentheses n minus 1. So now I'm only focusing on my numerator because my denominators are already the same. So from here, this becomes a multi-step equation. You learn these in Algebra 1, so you'll distribute. You'll get this when you do so. You'll collect your like terms, so it looks like this. And after I collected my like terms, I also put everything on the same side. You'll notice you now have a quadratic. You have several ways that you can solve quadratics: by factoring, completing the square, or you can use a quadratic formula. In this case, I'm going to go with factoring. So your GCF is going to be 5. And then you'll factor into these two parentheses, these two binomials. And when you solve each of these, you end up with these two answers. If you were to plug these back into the original problem, you would get the same answer, so you know that they're going to both work. Okay? Please go ahead and pause the video to check these. I don't do it in my notes because I don't have enough room to do so. For example 3, we have this equation. For this one, I'm going to use method 3, which is the exact same one that I used just now. So you can go ahead and pause your video and try this one on your own and see if you can do it. So the first thing we want to do is factor those bottoms so that we can see what the LCD is going to be when you go to combine those fractions. And that's going to be a plus 5, a plus 3. So these are the two parts that I'll multiply by: a plus 3 on the first fraction, and a plus 5 on the second fraction. You'll now notice that these two numerators are the same, so I'll go ahead and distribute over here on my numerators. And then on the right side of my numerator, I'm going to set them equal to each other, so now my tops must also be the same as well. This is also still a multi-step equation like you would see from your Algebra 1. So get all the like terms together and put everything on the same side. You'll factor and you'll solve, and you'll end up with a equals 1 and a equals negative 5. When you plug these back in, a equals 1 will work. And then if you plug in a equals negative 5 into the very beginning one, you actually end up with dividing by 0 in this first fraction. So you can't do that because it would have been excluded from the original domain in the first place. So I have to cross that one out. Okay? And then for the last example, example 4, I don't have it labeled, but this is actually going to use method 1. If you remember, method 1 was to multiply each side by the LCD. And so in this case, the LCD is going to be x plus 1 times x minus 1, because this is a difference of squares that factors. And so you're going to multiply both sides by x plus 1 times x minus 1. When you do that, this x plus 1, x minus 1, I technically should have a big, huge parentheses here because it's going to go to both pieces. So you'll multiply it by every single fraction. If there's 3 fractions, which there are here, you would multiply it by all 3 fractions, or how many ever fractions that you have, you'll multiply it. When you multiply this first fraction by the LCD, x plus 1, x minus 1, your x plus 1s will cancel, and you're left with 2 parentheses x minus 1. When you do it with the second fraction, you're left with simply x plus 1, but because there's a minus, I'm going to put a parenthesis around it so I can distribute that negative later. And then when you do it on the right-hand side, you're left with only a 2. Oh no, negative 2. I think it's supposed to be a positive 2. I think I wrote that down. It should be a positive 2 here. And so now, when I go to solve this, we'll get 2x minus 2 minus x, which is going to be x. You'll get the negative 2 minus positive 1, which is negative 3. And when you add that to both sides, you end up with x equals positive 1. So I think this original problem was supposed to be a negative here. Go ahead and put a negative here from the very beginning. That's my fault. I apologize. So put a negative there for me and a negative there for me so that it matches here. And so if you plug in x equals 1 back into this second equation here, or this third equation, you'll notice that it won't work because it would have been restricted from the domain, which means this has no solution. And that is it for this page.